This video is brought to you by School of PE. More about them later in the video. Will AI replace structural engineers? Short answer, yes. Get this all over then. Over. But wait, it's really not that bad. Before you go throwing in your career and stopping down the path of engineering, I think that's going to be a big mistake. Let's have a look at about how AI can actually be advantageous to your career. Yes, in the end, it may take over a lot of the responsibilities that we have. You see, AI may be good at those really repetitive tasks, but it's not really good at inventing new or innovative solutions. If we look at facts in such as Midjourney, which is a really great image generator, but you need to type in prompts. So it's the people behind it creating the creativity behind it. So if it's something that you've seen before, it can replicate it. But if it's something uniquely new that no one's ever tried before, it won't be able to replicate it. That's where human ingenuity comes into its own. And your job as an engineer, you may think it's just about doing the numbers and making sure a building is structurally safe. That's where you're wrong. See, engineering is about solving problems. You'll still have that responsibility and showing the client the right way. So you, as a combination, may be able to guide AI down the right direction with your innovative approach. Yes, eventually AI will be able to replace us. However, it will take a long time. And what facts do we have to back that up? Let's just have a look at how chess has been involved in computing and how long it actually took. You see, for a long time, computers, in this limited game of chess, there's only so many moves, nowhere near as complex as a building, weren't able to beat humans for the first time. You see, the first match was done with Kasparov and Deep Blue in 1996. During that match, Kasparov was able to beat the computer. Yes, it did win some games, but the overall match was won by Kasparov. There was a re-challenge in 1997, and this is where Deep Blue took a one-up and was able to manage to beat Kasparov, but it was still a close game. So this was the first time in history that a human grandmaster was beaten by a computer entity. You see, after this match with Deep Blue, for a long time, there was these joint hybrid groups. You see, the human could think about long-term strategy, while the computer could make sure that they don't make any fundamental mistakes. They were unbeatable for a long time. This lasted for about 20 years. And now, a computer, doesn't matter how good the person or hybrid combination is, the AI will always win. But that took a really long time to take over. And this was really with a limited number of subset of results. So if we come back to engineering, we can see some of this already happening now. A lot of time you are not doing just hand comps to design a building, using computer-aided designs. And AI is just another tool that you'll bring into your tool chest that will allow you to have safer buildings that are both more efficient. So you'll be able to have a look at a lot of different results. See, a lot of the time the computer will come up with a number of different results that may be correct or wrong. It'll be up to you to decide and evaluate each of them to see which way to go. It will also allow you to go back to the client with a number of different options, so you can give more variety, giving them more choice about what they have to select and what they can build with. And it'll be your ability to problem solve. That's really where the power of engineering comes in, about understanding structural mechanics. So moving forward, it's more about understanding the structural mechanics behind engineering, as opposed to actually knowing the code requirements. The computer will be able to deal with that. If you're just standing back and not trying to implement AI into your workflow, you will be taken over by these hybrid solutions, similar to what was happening with chess. And they'll have the person behind it with the smarts that has understanding of structural mechanics, leading to the best solutions. Where if you're just by yourself, you may lead to a lot of good results, but you won't be able to beat that hybrid group. They'll be able to produce results faster, cheaper, and more efficient both in design and in construction. But now, aren't you saying I don't need those hard skills? That's where you're wrong. Your hard skills are going to be even more important than they were before. Understanding true structural mechanics, how structures actually behave, and the forces and the stresses, how they flow through, will allow you to see those innovative solutions and solve those unique problems, similar to those hybrid groups with the chess champions. This video is brought to you by School of PE. The School of PE has been ranked as the #1 exam prep school for your either FE or PE exams, and it has a 93% pass rate, which is much higher than the national average of 61%. So, what do they offer? They offer a structured course to help you prepare for that exam. Even after the lecture, you still have access for the next 90 days. So you can revise the critical areas where you need to work more on. Not only do they provide both those written materials and online lectures, they also provide a number of different other tools to help you memorize and prepare for that day, such as flashcards, quizzes, pop quizzes, and test exam questions, so you can be thoroughly prepared before sitting your exam. They also have 24/7, 7 days a week support. If you're looking to sit your PE or FE exams, or just looking to brush up on your engineering knowledge, it's a great place to go. And don't forget to check out the link in the below description. Now let's get back to the content. There is already things in engineering where you can actually use some evolutionary design. It's not really AI, but it's using a computer-based aided design to come up with different solutions. So you've got things in Rhino such as Galapagos, which does an evolutionary design, typically leads to a lot of different crazy results. A lot of them are probably structurally efficient, but they'll be really impossible and crazy to build. For example, having sizes changing randomly through the whole building means it's more likely to cause errors and putting the wrong piece in the wrong place. Or might have some brace going through some weird direction that would be really odd when you look at it in person. Yes, there's probably some load going somewhere, but is it really the result that you want? And we can see this in some of the crazy shapes that you can 3D print, especially when they're going down the minimalist approach. Got these really organic shapes where the loads are transferring through in the most efficient way possible. They really look like masterpieces of engineering. You can see the forces, how they're going through, and how that actually organic approach to design is super efficient. But when you're building a big building, it's not really the most practical way. Yes, it may be efficient for one component. For example, these areas where you've got a specific area where you've got a bespoke load that needs to go through it. However, overall structure is not built in that way. Even as it's built with computers, it just makes it more harder to build and makes it not really manufacturable, which is the approach that we need to go down. That while the computers will be able to come up with a more efficient solution, you need to filter out all those different crazy ideas. A lot of time the computer, especially at the moment, can only get between 70 to 80% of the way there. Yes, it's probably lead to a more efficient design than what you had before, but then when you look at those results, you make a little bit of tweaks. You can bring it from that 70, 80% all the way up to 80, 90 or 95% more efficient. So it allows you not only to guide the direction of where the design is going to a more efficient design, but also means that you're using the computer in the most efficient way possible. But it does mean that your structural mechanics is more important than ever. That's really where your responsibilities lie, coming up with those unique and innovative solutions. Being that first person to think about how something approaches, being the person how we can actually frame something up, going back to the roots of engineering. See, back in the day, engineers were also architects, building magnificent masterpieces, such as Brunelleschi's dome. You see, he was not only an engineer, but he was also an architect of these magnificent structures. It took a long time for computers to catch up from such a simple approach. So it will mean for a long time, the best way that engineers can move forward is in that hybrid approach that we're currently doing now, but integrating more of those tools into our workflow, making sure we're more efficient and leading to safer results. So don't see it as a negative, see it as a benefit and embrace it in your career. And it's going to be a really long time before AI completely takes over and completely subverses your job so you're not needed at all. The computer for chess took 20 years. Buildings are so much more complicated with so many different variables that can come into play. If you've got a limited subset of results, yes, it's quite easy. But when you've got the infinite mindset of any type of building, this will take a lot longer. So you're many, many years off this from occurring. Will a lot of new builds be designed by AI and not need a lot of human input in the long term? Yes. However, this is a good thing because it means that you can focus on what truly matters and truly understanding structural mechanics, and instead of just trying to make sure that you're meeting all those specific code requirements. So there's a really exciting future ahead for us as engineers. And it's up to you to make sure you're embracing and getting those workflows, getting rid of a lot of that boring tasks and using AI to your biggest advantage. And if you want to learn more about concrete design, I've got a video here that'll make your concrete designs to the next level. And if you're interested in supporting the channel, there's 2 ways that you can do this. You can either become a YouTube or Patreon member. As without the support of my YouTube and other Patreon members, this type of content would not be possible. And as always, stay safe, keep learning, and I'll see you next week. Bye.